Hello everyone, how are you doing? I hope you all are fine. Due to my busy schedule, I was not able to make any videos. I am extremely sorry for that. Today we are going to solve the remaining trigonometric identities of exercise 7. I hope you like my video, so please stay with me till the end of this video. Let's continue. Question number 3, prove that cos theta by 1 minus sin theta equals to 1 plus sin theta by cos theta. Taking left hand side, we have cos theta by 1 minus sin theta. Let's see on the right hand side, we have 1 plus sin theta. So let's multiply the numerator and denominator of this left hand side with 1 plus sin theta. So cos theta by 1 minus sin theta into 1 plus sin theta by 1 plus sin theta. Since these two terms, they are same term and they get cancelled and the result becomes the same, so we can multiply the numerator and denominator with the same terms or same expression. So cos theta into 1 plus sin theta by 1 plus sin theta into 1 minus sin theta. They are in the form a plus b into a minus b. So a plus b into a minus b, it becomes a square minus b square. Here 1 is in the form a and sin theta, it is in the form b. So 1 plus sin theta into 1 minus sin theta, a plus b into a minus b, it becomes a square, that is 1 square, which is 1 minus b square sin square theta. Cos theta into 1 minus sin theta, sorry, it is plus here, by 1 minus sin square theta. As we know that sin square theta plus cos square theta equals to 1. So cos square theta would be equal to, when sin square theta is transferred to right hand side, it becomes 1 minus sin square theta. So 1 minus sin square theta can be written as cos square theta. So cos square theta in the numerator and 1 cos theta in the denominator, they get cancelled. So we have the remaining terms 1 plus sin theta by cos theta, which is our right hand side. Hence it is proved. Let's see the next question. Is similar to the previous one. Sin theta by 1 minus cos theta equals to 1 plus cos theta by sin theta. Taking left hand side, we have sin theta by 1 minus cos theta. On the right hand side, we can see that on the numerator we have 1 plus cos theta. So let's multiply the left hand side with 1 plus cos theta on the numerator as well as in the denominator. So sin theta by 1 minus cos theta into 1 plus cos theta by 1 plus cos theta. Sin theta into 1 plus cos theta by 1 plus cos theta into 1 minus cos theta. They are in the form a plus b into a minus b. So a plus b into a minus b is a square minus b square. So it is a square, that is 1 square, which is 1 minus b square. Here b is cos theta, so b square becomes cos square theta. Sin theta into 1 plus cos theta by 1 minus cos square theta is equal to sin square theta. So sin theta on the numerator and 1 sin theta on the denominator, they get cancelled. We have the remaining terms 1 plus cos theta by sin theta. Which is our right hand side. The next question, sin theta by 1 plus cos theta plus 1 plus cos theta by sin theta equals to 2 cosec theta. So taking left hand side, we have sin theta by 1 plus cos theta plus 1 plus cos theta by sin theta. Now taking the LCM of these two denominators, we can see that the denominators are different terms. So when we take the LCM of the two different denominators, then both shall be written in the denominator. These both shall be written in the denominator at their LCM. So 1 plus cos theta into sin theta. Now we shall divide 1 plus cos theta into sin theta with 1 plus cos theta. So 1 plus cos theta and 1 plus cos theta, they get cancelled. The remaining term is sin theta. So sin theta into sin theta, it becomes sin square theta plus. Now let's divide this denominator again with this sin theta. So 1 plus cos theta into sin theta divided by sin theta cancel. 1 plus cos theta into 1 plus cos theta, it is 1 plus cos theta whole square. As we know that x into x equals to x square, a into a equals to a square. Similarly, a plus b into a plus b, it becomes a plus b whole square. In the same way, 1 plus cos theta into 1 plus cos theta is 1 plus cos theta whole square. Now sin square theta plus, let's expand this 1 plus cos theta whole square. A plus b whole square can be expanded as a square plus 2ab plus b square. That's in the law. A plus b whole square can be written as a square plus 2ab plus b square. So a square, that is 1 square, plus 2ab, 2 into a, which is 1, into cos theta, 2 cos theta, 2 into 1, 2, 2 into cos theta, 2 cos theta, plus b square, that is cos square theta, by 1 plus cos theta into sin theta. Sin square theta plus cos square theta is equal to 1. So sin square theta plus cos square theta we can write as 1 plus 1 plus 2 cos theta by 1 plus cos theta into sin theta. 1 plus 1, 2, 2 plus 2 cos theta by 1 plus cos theta into sin theta. We can take the common between these two terms. So 2 is the common between these two terms. 2 common, 1 plus cos theta by 1 plus cos theta into sin theta. We can cancel this 1 plus cos theta in the numerator and 1 plus cos theta in the denominator. So it's 2 by sin theta. So 2 by sin theta is 2 into 1 by sin theta. So 1 by sin theta, it is cosec theta. So 2 into 1 by sin theta is cosec theta, which is our right hand side. One by 1 minus cos theta plus 1 by 1 plus cos theta equals to 2 cosec square theta. Taking left hand side, we have 1 by 1 minus cos theta plus 1 by 1 plus cos theta. Now we shall take the LCM of 1 minus cos theta and 1 plus cos theta. So when we take the LCM, we write these both terms at their LCM. That is 1 minus cos theta into 1 plus cos theta. Since they are different terms, or we can say they are different expressions, so the LCM of these two different terms or expression would be both. We shall take this both. Now divide 1 minus cos theta into 1 plus cos theta by 1 minus cos theta. So 1 minus cos theta and 1 minus cos theta, they get cancelled. The remaining is 1 plus cos theta. So 1 plus cos theta into 1 plus cos theta plus 1 minus cos theta, 1 minus cos theta, cancelled. 1 minus cos theta into 1 minus cos theta. We can cancel plus cos theta and minus cos theta. Now we have 1 plus 1, 2 by 1 plus cos theta into 1 minus cos theta. A plus b into a minus b is a square minus b square. So a square, that is 1 square, which is 1 minus b square cos square theta 2 by 1 minus cos square theta is equal to sin square theta. Now I can write this as 2 into 1 by sin square theta. 2 into 1, 2 by sin square theta. So 2 into 1 by sin square theta is cosec square theta, which is our right hand side. Question E, 1 by 1 minus sin theta minus 1 by 1 plus sin theta equals to 2 sin theta into sec square theta. So taking left hand side, we have 1 by 1 minus sin theta minus 1 by 1 plus sin theta. Now taking the LCM of these both expressions, 1 minus sin theta, 1 plus sin theta, both shall be taken at the LCM. 1 minus sin theta into 1 plus sin theta. 1 minus sin theta and 1 minus sin theta, they get cancelled. The remaining expression is 1 plus sin theta. So 1 plus sin theta into 1 plus sin theta minus 1 plus sin theta and 1 plus sin theta, they get cancelled. The remaining expression is 1 minus sin theta. So 1 minus sin theta into 1, it would be 1 minus sin theta. But we have to take a bracket. Since there is minus and after minus I am going to write this expression which contains two terms. So I should give you a bracket. So bracket 1 minus sin theta. 1 plus sin theta minus into 1 minus into minus plus sin theta by 1 plus sin theta, 1 minus sin theta. They are in the form a plus b into a minus b. So a plus b into a minus b, it would be a square minus b square. So a square, that is 1 minus b square sin square theta minus 1 plus 1. They get cancelled. The remaining terms, sin theta plus sin theta, 2 sin theta by 1 minus sin square theta, which is equal to cos square theta. I have wrote this upper part. Continuing from here, 2 sin theta by cos square theta can be written as 2 sin theta into 1 by cos square theta. 2 sin theta into 1, 2 sin theta by cos square theta. It's the same. So 2 sin theta into 1 by cos square theta is equal to sec square theta, which is our right hand side. The next question, 1 by 1 minus cos alpha minus 1 by 1 plus cos alpha equals to 2 cot alpha into cosec alpha. So taking the left hand side, we have 1 by 1 minus cos alpha minus 1 by 1 plus cos alpha. This question is similar to the previous one. Here also we shall take these both expressions as their LCM. So 1 minus cos alpha into 1 plus cos alpha. So 1 minus cos alpha and 1 minus cos alpha, they get cancelled. The remaining expression is 1 plus cos alpha, 1 plus cos alpha into 1 plus cos alpha minus 1 plus cos alpha and 1 plus cos alpha, they get cancelled. The remaining expression is 1 minus cos alpha. So 1 minus cos alpha into 1, it will be 1 minus cos alpha. And I have to write this in bracket. So 1 minus cos alpha equals to 1 plus cos alpha minus 1 minus into minus plus cos alpha by 1 plus cos alpha into 1 minus cos alpha. They are in the form a plus b into a minus b. So a square minus b square, that is 1 square, which is 1 minus b square, that is cos square alpha, minus 1 plus 1, they get cancelled. So plus cos alpha, it will be 2 cos alpha by 1 minus cos square alpha, it will be sin square alpha, equals to, now let's see on the right hand side, we have 2 cot alpha into cosec alpha. So as we know that cot alpha is equal to cos alpha by sin alpha. I have here cos alpha and I need sin alpha in the denominator. So I can break this sin square alpha into 2 parts. That is sin alpha into sin alpha. So 2 cos alpha by sin square alpha can be written as sin alpha into sin alpha. Now 2 cos alpha by sin alpha is equal to cot alpha. So cot alpha into 1 by sin alpha is equal to cosec alpha, which is our right hand side, which is proved. The next question, 1 by 1 minus cos theta minus 1 by 1 plus cos theta equals to 2 cos theta into cosec square theta. This question is similar to question number E, that is the process is same. So taking left hand side, 1 by 1 minus cos theta minus 1 by 1 plus cos theta, taking the LCM of these both expressions, 1 minus cos theta into 1 plus cos theta. This expression they get cancelled. The remaining expression is 1 plus cos theta. So 1 plus cos theta into 1 plus cos theta minus 1 plus cos theta, they get cancelled. The remaining expression 1 minus cos theta. So 1 minus cos theta into 1, it would be 1 minus cos theta. I shall write in bracket 1 minus cos theta, 1 plus cos theta minus 1, minus into minus plus cos theta by 1 plus cos theta, 1 minus cos theta, a plus b, a minus b, a square minus b square. So 1 square, that is 1 minus cos square theta minus 1 plus 1, they get cancelled. Now we have cos theta plus cos theta, 2 cos theta by 1 minus cos square theta, which is equal to sin square theta. Let's see on the right hand side, we have 2 cos theta. We have already obtained 2 cos theta and I need cosec square theta. So it can be written as 2 cos theta can be written as 2 cos theta into 1. 2 cos theta into 1, it will be 2 cos theta. So 2 cos theta, I have got a 2 cos theta. 1 by sin square theta is equal to cosec square theta. So 2 cos theta, I shall write separately 2 cos theta into 1 by sin square theta is equal to cosec square theta, which is our right hand side. Cos x by 1 by sin x plus cos x by 1 plus sin x equals to 2 sec x. So taking left hand side, we have cos x by 1 minus sin x plus cos x by 1 plus sin x. As usual, taking the LCM of these both expressions, we have 1 minus sin x into 1 plus sin x. So 1 minus sin x, they get cancelled. The remaining expression 1 plus sin x into cos x. So cos x into 1 plus sin x plus 1 plus sin x, 1 plus sin x, they get cancelled. Remaining expression 1 minus sin x, 1 minus sin x into cos x into 1 minus sin x. Cos x into 1, cos x plus cos x into sin x cos x, or you can write down cos x sin x, it makes no difference, plus cos x into 1 cos x plus into minus cos x into sin x cos x, or cos x sin x, by 1 plus sin x, 1 minus sin x. They are in the form a plus b, a minus b. So we can write a square, that is 1 square, which is 1, minus b square, that is sin square x, plus sin x cos x minus sin x cos x, they get cancelled. Continuing from here, cos x plus cos x, we have 2 cos x by 1 minus sin square x is equal to cos square x. So 1 cos x in the numerator and 1 cos x in the denominator, they get cancelled. So we have 2 by cos x. So 2 by cos x can be written as 2 into 1 by cos x. 2 into 1, 2 by cos x. So 2 into 1 by cos x is equal to sec x. That is 2 sec x, which is our right hand side. Let's see the next question. 1 minus tan a by 1 plus tan a equals to cot a minus 1 by cot a plus 1. Taking left hand side, we have 1 minus tan a by 1 plus tan a. Let's see on the right hand side, we have cot a both on numerator and denominator. That is, this both tan a should be converted in terms of cot a. So let's convert 1 minus tan a is equal to 1 by cot a by 1 plus 1 by cot a. Now how to simplify this? 1 minus 1 by cot a. Let's say in the raw 2 plus 3 by 5. So it can be simplified as 5 2s are 10 plus 3, 13 by 5. Similarly, 4 plus 3 by 6, it can be simplified as 6 4s are 24 plus 3, 27 by 6. In the same way, 1 minus 1 by cot a can be simplified as cot a into 1, cot a minus 1 by cot a. Now this also can be simplified in the same process, cot a into 1, cot a plus 1 by cot a. Let's say in this upper part and lower part, both in the denominator there is cot a. So this cot a and this cot a, they can be cancelled. Since in the both denominator there is cot a, so they can be cancelled. So we have the remaining expression cot a minus 1 by cot a plus 1, which is our right hand side. Now let's prove this identity by another way. But before proving, let's say in the raw, I want to make you one thing clear. Suppose we are given a fraction 4 by 5. Then we can divide this numerator and denominator with any integer we like except 0. If we divide with 0, then this term would be undefined. So we can divide the numerator and denominator with any integer we like. Like I can divide this by 3, 4 by 3, by 5 by 3. The common integer 3. I can divide them by minus number minus 2, 5 by minus 2 with a common integer minus 2. Similarly, here also in the numerator and denominator, let's divide them by tan a. So 1 by tan a minus tan A by tan A. By, in the denominator also, let's divide with tan A. 1 by tan A plus tan A by tan A. This tan A and this tan A, they get cancelled, as well as in the denominator also, this both tan A would get cancelled. Now we have remaining terms. 1 by tan A is equal to cot A minus 1, tan A by tan A 1 by 1 by tan A cot A plus 1, which is our right hand side. Let's see the next question. 1 minus cos power 4a by sin power 4a equals to 2 cot square a. So taking left hand side, we have 1 minus cos power 4a by sin power 4a. This 1 can be written as 1 square minus cos power 4a can be written as cos square a whole square. Let's see in the law. In laws of indices, we have studied according to the power rule. If any base has got power and again it is enclosed in another power, then both powers would get multiplied. It would be a power 2 to the 4. Similarly, 5 power 3 power 2. 3 to the 6. 5 power 6. In the same way, cos square a whole square. So, power 2 into power 2, it would be power 4. So, cos power 4a can be written as cos square a whole square by sin power 4a. It's in the form a square minus b square. Here a is 1 and b is cos square a. So, a square minus b square we can write as a plus b, that is 1 plus b, here b is cos square a, into a minus b. So a, which is 1, minus b, that is cos square a, by sin power 4a equals to 1 plus cos square a into 1 minus cos square a is equal to sin square a by sin power 4a can be broken as sin square a into sin square a. We can cancel the sin square a in the numerator and sin square a in the denominator. Let's separate this 1 plus cos square a. When we separate 1 plus cos square a, sin square a is taken by 1 as well as cos square a. So 1 by sin square a plus cos square a by sin square a. One by sin square a is equal to cosec square a. Cos square a by sin square a is equal to cot square a. Cosec square a can be written as 1 plus cot square a plus we have another cot square a together. 1 plus cot square a plus cot square a plus 2 cot square a, which is our right hand side. This is similar to previous question. 1 minus sin power 4a by cos power 4a equals to 1 plus 2 tan square a. Taking left hand side, 1 minus sin power 4a by cos power 4a. 1 can be written as 1 square minus sin power 4a can be written as sin square a whole square by cos power 4a. It is in the form a square minus b square, that is 1 plus sin square a, that is a plus b, 1 minus sin square a, that is a minus b, by cos power 4a. equals to 1 plus sine square A into 1 minus sine square A, which is equal to cos square A, by cos power 4A can be broken as cos square A into cos square A. Cos square A in the numerator and cos square A in the denominator, they get cancelled. Let's separate this 1 plus sine square A, 1 by cos square A. This cos square A is taken by 1 as well as sine square A, plus sine square A by cos square A. 1 by cos square A is equal to sec square A, plus sine square A by cos square A is equal to tan square A. Sec square A can be written as 1 plus tan square A plus tan square A. So it becomes 1 plus tan square A plus tan square A equals to 2 tan square A, which is our right hand side. So it is proved. Here we have the next question. Sin cube A plus cos cube A by cos A plus sin A equals to 1 minus sin A into cos A. Taking left hand side, we have sin cube A plus cos cube A by cos A plus sin A. We can say that it's in the form A cube plus B cube. That is, sin A acts as A and cos A acts as B. So A cube plus B cube. What is the formula of A cube plus B cube? A cube plus B cube is equal to A plus B, A square minus AB plus B square. So let's write them in the form A cube plus B cube. That is in the formula of A cube plus B cube. A plus B, that is sin A plus cos A square, that is sin square A, minus AB, that is sin A into cos A, plus B square, that is cos square A, by cos A plus sin A. Sin A plus cos A plus sin A, they are same, so they get cancelled. We have here sin square A plus cos square A. Let's combine the sin square A with cos square A. Sin square A plus cos square A, which is equal to 1 minus sin A into cos A, which is our right hand side. That is RHS proved. Now let's come to question number 4. We have here 1 by sec theta plus tan theta equals to 1 minus sin theta by cos theta. So taking left hand side, we have 1 by sec theta plus tan theta. Let's say in the denominator we have sec theta plus tan theta. So to reduce this sec theta plus tan theta, let's write this 1 in the form sec square theta minus tan square theta. Since sec square theta minus tan square theta equal to 1, so I can write this 1 as sec square theta minus tan square theta. I know the sec square theta minus tan square theta by seeing this denominator, by sec theta plus tan theta. Now we can say that it's in the form A square minus B square. Sec square theta minus tan square theta. Here sec theta is like A and tan square theta acts as B. So sec square theta minus tan square theta can be written as sec theta plus tan theta into sec theta minus tan theta by sec theta plus tan theta. Let me keep the sec theta plus tan theta of denominator in the bracket. Now I can cancel this sec theta plus tan theta and this denominator sec theta plus tan theta. Now there remains sec theta minus tan theta. Let's see further. Sec theta can be written as 1 by cos theta minus tan theta can be written as sin theta by cos theta. Cos theta, they are common. So the LCM would be cos theta 1 minus sin theta, which is our right hand side. Let's see the next question. It is similar to the previous one. 1 by cosec theta plus cot theta equals to 1 minus cot theta by sin theta. Taking left hand side, we have 1 by cosec theta plus cot theta. Let's say in the denominator we have cosec theta plus cot theta. So we can write this 1 as cosec square theta minus cot square theta. Since cosec square theta minus cot square theta would be equal to 1. So 1 is equal to cosec square theta minus cot square theta by cosec theta plus cot theta. It's in the form a square minus b square, where cosec theta acts as b and cot theta acts as cosec theta acts as a and cot theta acts as b. So a square minus b square, which is a plus b, that is cosec theta plus cot theta into a minus b, that is cosec theta minus cot theta by cosec theta plus cot theta. Let me keep this in bracket. So this cosec theta plus cot theta of numerator and this cosec theta plus cot theta of denominator, they get cancelled. Now we have cosec theta minus cot theta. Cosec theta is equal to 1 by sin theta minus cot theta is equal to cos theta by sin theta. The denominator are same, so we can take them as LCM, the same. 1 minus cos theta, which is our right hand side. Let's see the next question. 1 by cot theta plus tan theta equals to sin theta into cos theta. If we see on the right hand side, we can see that there are sin theta and cos theta. It means we have to change this cot theta and tan theta in terms of sin theta and cos theta. So taking left hand side, we have 1 by cot theta plus tan theta equals to 1 by, change cot theta in terms of cos theta by sin theta, and this tan theta in terms of sin theta by cos theta. Now let us say in this part we have to simplify them. So while simplifying, we shall take the LCM of sin theta and cos theta. So the LCM of sin theta and cos theta would be sin theta into cos theta. So 1 by, take the LCM of sin theta and cos theta, sin theta into cos theta. We are operating on this lower part. So sin theta and sin theta cancel. We have the remaining term cos theta into cos theta. We have cos square theta plus cos theta and cos theta cancel. We have the remaining term sin theta. Sin theta into sin theta, we have sin square theta equals to 1 by cos square theta plus sin square theta is equal to 1 by, we have sin theta into cos theta. When this lower part goes up, it becomes reciprocal. Now we can write as 1 into, now it is reciprocal. When it goes up, it becomes sin theta into cos theta by 1. No need of cancelling this one and this one, since their multiplication, that is their product, would be the same thing. So 1 into sin theta into cos theta, sin theta, cos theta by 1, no need to write. So we got our right hand side. One by sec theta minus tan theta equals to 1 plus sin theta by cos theta. Taking left hand side, we have 1 by sec theta minus tan theta. Let's write 1 at the relation which would match with sec theta minus tan theta. So what would be the relation of 1 which would match with sec theta minus tan theta? Obviously it is sec square theta minus tan square theta by sec theta minus tan theta. Since sec square theta minus tan square theta would be equal to 1, and which would match with this denominator. So I change this one in terms of sec square theta minus tan square theta. So it is in the form a square minus b square. So a square minus b square can be written as a plus b, that is sec theta plus tan theta, into a minus b, that is sec theta minus tan theta, by sec theta minus tan theta. I shall keep this in bracket. Now this sec theta minus tan theta in the denominator and this sec theta minus tan theta in the numerator, they get cancelled. We have the remaining terms sec theta plus tan theta. Let's see on the right hand side, we have 1 plus sin theta by cos theta. So let's change the sec theta in terms of 1 by cos theta. We have 1 by cos theta plus tan theta can be written in terms of sin theta and cos theta, that is sin theta by cos theta. Let's take the LCM of cos theta and cos theta. So it will be cos theta, the same denominator, so their LCM would be the same, 1 plus sin theta. We can write this numerator part as they are. So it's our right hand side. Let's see the next question. Cos theta by cosec theta plus 1 plus cos theta by cosec theta minus 1 equals to 2 tan theta. So taking left hand side, cos theta by cosec theta plus 1 plus cos theta by cosec theta minus 1. While taking the LCM of these two expressions, we shall take both of them. Since cosec theta plus 1 and cosec theta minus 1, they are entirely the different expressions. So let's take the both expressions as their LCM. Cosec theta plus 1 and cosec theta plus 1, they get cancelled. The remaining expression cosec theta minus 1 is to multiply cos theta. So cos theta into cosec theta minus 1 plus cosec theta minus 1 and this cosec theta minus 1, they get cancelled. Now the remaining expression is cosec theta plus 1. So cosec theta plus 1 into cos theta. The cos theta should multiply cosec theta plus 1. Now let's multiply this cos theta with cosec theta minus 1. So cosec theta into cos theta into cosec theta minus cos theta into 1 cos theta plus cos theta into cosec theta cos theta cosec theta plus cos theta into 1 cos theta by cosec theta plus 1 into cosec theta minus 1. They are in the form a plus b, a minus b. So a plus b into a minus b, it can be written as a square minus b square, that is cosec square theta minus 1. We can see that minus cos theta and plus cos theta, they get cancelled. Now the remaining cos theta into cosec theta plus cos theta into cosec theta, that is 2 cos theta into cosec theta by cosec square theta minus 1 equals to cot square theta. Continuing from here, let's separate this cot square theta. 2 cos theta into cosec theta into 1 by cot square theta. Since 2 cos theta into cosec theta into 1, it will be the same 2 cos theta cosec theta by cot square theta. Now 2 cos theta into cosec theta can be written as 1 by sin theta into 1 by cot theta, it will be tan theta. So 1 by cot square theta can be written as tan square theta. 2 cos theta into 1 by sin theta into tan square theta can be written as sin square theta by cos square theta. Let's cancel this cos theta, 1 cos theta in the numerator and 1 cos theta in the denominator. Similarly, let's cancel this sin theta in the denominator and 1 sin theta in the numerator. So we have now 2 into 1, 2 sin theta by cos theta. Let's see. 2 into 1, 2, 2 into sin theta, 2 sin theta by, we have in the denominator cos theta. Let's combine the sin theta by cos theta, it will become tan theta. So we got 2 tan theta, which is right hand side. Root under 1 plus sin theta by 1 minus sin theta equals to sec theta plus tan theta. So let's start from left hand side. We have root under, that is square root under 1 plus sin theta by 1 minus sin theta. Now let's multiply the numerator and denominator with 1 plus sin theta. In the denominator there is 1 minus sin theta. So let's multiply with the opposite sign given in the denominator. So root under 1 plus sin theta by 1 minus sin theta into 1 plus sin theta by 1 plus sin theta. It's called rationalizing. 1 plus sin theta, 1 plus sin theta, they get cancelled. Its value would be equal to 1. 1 into this is the same. So root under 1 plus sin theta into 1 plus sin theta. It would be 1 plus sin theta whole square. Since x into x, it would be x square. Y into y, it would be y square. Similarly, 1 plus sin theta into 1 plus sin theta, it would be 1 plus sin theta whole square. By 1 plus sin theta into 1 minus sin theta, that is a plus b into a minus b. We have a square minus b square. A square, that is 1 square, which is equal to 1 minus b square, which is sin square theta. Equals to root under 1 plus sin theta whole square, as it is 1 plus sin theta whole square by 1 minus sin square theta is equal to cos square theta. Let's keep 1 plus sin theta and cos theta under the same square. So square root 1 plus sin theta by cos theta whole square. Now we can cancel this square root and this square. We have the terms left 1 plus sin theta by cos theta. Let's separate 1 and sin theta. So when we separate 1 and sin theta, cos theta is taken by these both terms. So it becomes 1 by cos theta plus sin theta by cos theta. 1 by cos theta is equal to sec theta plus sin theta by cos theta is equal to tan theta, which is our right hand side. Proved. Let's see the next question. This question is similar as before. Left hand side, root under 1 minus cos A by 1 plus cos A. Let's say in the denominator there is 1 plus cos A. So let's multiply the numerator and denominator with a conjugate of 1 plus cos A. So the conjugate of 1 plus cos A is 1 minus cos A. The conjugate of A plus B is A minus B. So 1 plus cos A, its conjugate would be 1 minus cos A. So let's multiply the numerator and denominator. 1 minus cos A by 1 plus cos A into 1 minus cos A by 1 minus cos A. Root under 1 minus cos A into 1 minus cos A, it would be 1 minus cos A whole square by 1 plus cos A into 1 minus cos A. A plus B into A minus B, A square minus B square. So A square, that is 1 square, which is 1 minus B square, that is cos square A, equals to square root under 1 minus cos A whole square as it is by 1 minus cos square A is equal to sin square A. Now let's keep 1 minus cos A and sin A under the same square. 1 minus cos A by sin A whole square. Now we can cancel square root and square. The remaining terms 1 minus cos A by sin A. Let's separate 1 and cos A, that is 1 and minus cos A. So when we separate these two terms, sin A is taken by these both terms. So 1 by sin A minus cos A by sin A. 1 by sin A is equal to cosec A minus cos A by sin A is equal to cot A, which is our right hand side. The next question, it is also similar as previous question. So left hand side, root under 1 minus sin theta by 1 plus sin theta. Now multiply numerator and denominator with the conjugate of 1 plus sin theta. So the conjugate of 1 plus sin theta is 1 minus sin theta. So root under 1 minus sin theta by 1 plus sin theta into 1 minus sin theta by 1 minus sin theta. 1 minus sin theta into 1 minus sin theta, 1 minus sin theta whole square by 1 plus sin theta into 1 minus sin theta, A plus B into A minus B is A square minus B square. So A square, 1 square, 1 minus sin square theta. root under 1 minus sin theta whole square as it is by 1 minus sin square theta is equal to cos square theta, keeping them both under the same square. So square root under 1 minus sin theta by cos theta whole square. Now cancelling the square root and square, the remaining terms 1 minus sin theta by cos theta. Let's separate these two terms. 1 by cos theta minus sin theta by cos theta. 1 by cos theta, sec theta, minus sin theta by cos theta, tan theta, which is our right hand side. This question is also similar as before, multiplying the numerator and denominator with a conjugate of 1 minus cos theta, that is with 1 plus cos theta. Let's see. Left hand side we have 1 plus cos theta by 1 minus cos theta equal to root under 1 plus cos theta by 1 minus cos theta into the conjugate of 1 minus cos theta, 1 plus cos theta. So 1 plus cos theta into 1 plus cos theta, 1 plus cos theta whole square. By a plus b into a minus b, a square minus b square, that is 1 square, that is 1 minus cos square theta equals to root under 1 plus cos theta whole square, same, by 1 minus cos square theta sin square theta, keeping these both under the same square, 1 plus cos theta by sin theta whole square. Now cancelling the square root and square, now the remaining terms left 1 plus cos theta by sin theta. Let's separate these both terms, 1 and cos theta. 1 by sin theta plus cos theta by sin theta. We have 1 by sin theta is equal to cosec theta plus cos theta by sin theta is equal to cot theta, which is right hand side. This is also similar as before, but at the end it is a little bit twisted. So let's see. Left hand side we have root under sec a plus 1 by sec a minus 1. Now multiplying the numerator and denominator with the conjugate of sec a minus 1, it is sec a plus 1. So sec a plus 1 by sec a minus 1 into sec a plus 1 by sec a plus 1. Root under sec a plus 1 into sec a plus 1, it is sec a plus 1 whole square by sec a plus 1 into sec a minus 1, a plus b into a minus b, it is a square, that is sec square a minus 1 square, that is 1, equals to square root under sec a plus 1 whole square as it is by sec square a minus 1 equal to tan square a. Now keeping them in same square, we have sec a plus 1 by tan a whole square. So square root and square they get cancelled. Now let's separate sec a and 1. We have sec A by tan A plus 1 by 1 by tan A. Let's convert sec A in terms of cos A, that is 1 by cos A by, and tan A in terms of sin A and cos A, that is sin A by cos A plus 1 by tan A in terms of sin A and cos A, sin A by cos A. We can cancel this denominator cos A and this denominator cos A of both parts. The remaining terms 1 by sin A plus in this lower portion there is sin A by cos A. So when it goes up, it becomes cos A by sin A. So cos A by sin A. Now continuing from here, sin A and sin A, we can take the LCM. So the LCM is sin A. Since in the denominator there is both sin A, so sin A comes as LCM. Now we can write this numerator part as they are, 1 plus cos A, which is our right hand side. Well, this was the end of this exercise. I'll be back in the next video with some more trigonometric identities. Till then, have a good day. Take care. Bye bye.